In example 2, we're going to get information about the velocity in feet per second, again, of a particle moving along the x-axis over a time interval from 0 to 9. But the information that we're going to gather about this moving particle is going to be from a graph. Okay, keeping in mind as well, x of t is the position, v of t is the velocity, and a of t is the acceleration. And so number 1, at t equals 4 seconds, which is right there, is the particle moving to the right or to the left? Well, if you look at the graph, this is the graph of v of t, and so we see that v of 4 is equal to, what is that, a 6? 6, which is greater than 0. So we have the particle moving to the right, because v of 4, which is equal to 6, is greater than 0. Okay, that's the explanation. That's all you need to write. Okay, let me back up a little bit. For number 2, over what time interval is the particle moving to the left? Well, moving to the left means that the velocity is less than 0. Left, when the velocity is less than 0, which means the velocity graph is under the t-axis. And so we can see the velocity at 5 is equal to 0, and then beyond 5, from t equals 5 to 9, from, let's see, left, v of t is less than 0, on the interval from 5 to 9, including 9, but not including 5. Okay? Number 3, at t equals 4 seconds, is the acceleration of the particle positive or negative? Okay. Well, we know that the acceleration of 4, at 4, is the velocity, is the derivative of the velocity at 4. And if we just look at the graph, we know that the derivative is the slope of the graph, okay, or the slope of the tangent line at a point. And so we can see the slope of v of t is negative. So we would say the slope of v of at 4 is negative. Therefore, the acceleration is negative. So we have a negative acceleration. That's it. That's the explanation. Okay? And then we're going to hold off on 4 and 5, and we'll pick up the very last example in the next video.